Hello everyone, welcome to another new video where we are going to see bubble sort. This is one of the algorithms to sort the given array of elements. Okay. Before going directly into the coding, let me explain you how the bubble sort work and why the name bubble sort. Now let's imagine that there is a container, something like this, and there are some bubbles generated for some reason. Maybe you have you are heating the vessel, okay, and there are some small bubbles generated, bigger bubbles. You should know that this bigger bubble will have higher buoyancy, that's why it will start rising first, and the smaller one becomes bigger, then it will start rising. So you should know that bigger bubbles bigger bubbles rise on the top, rise on the top. We are going to use the same method to identify which is a bigger value and then try to sort the given array. Okay, let me go to the numerical example. This was a real life example from where we have actually observed how what is the different, what are the different ways of sorting. Okay, let me take a simple example: 5 3 7 4 2 1. Okay, this is going to be our array, and you can clearly observe that this particular array is not sorted. So you are going to sort it in ascending order. Ascending order means the smaller one will be in the front and the larger one will be at the end. So just by looking at this, you will be able to say what is the smaller value and the bigger value. But when you are making the systems to solve the problems of sorting and all, you should understand that there are different algorithms, and today we are going to see the bubble sort algorithm. Okay, now before, as I said, before going into the coding, you need to understand how the bubble sort works. Okay, now just by my intuition I am going to explain you. Now let's imagine that you need to identify, you need to push, your main goal is to push all the greater values at the end. Okay, on this side, because you are going to convert it into ascending ordered array. Right, now, so what is the first element here? 5. Second element is 3. So just identify which one is bigger. Your duty is to make sure that the greater values come at the end. So there is a swapping required here. So you are going to swap, and this will be modified 3 5 7 4 2 1. Right, now you are going to check these both. You observe here, actually I started from here, this part j is equal to 0 and then j is equal to 1, and I swapped both of them. You can observe here, if j is equal to I, j will be equal to I plus 1. Means this j, we are going to compare the adjacent values. Okay, this is very important when you are writing the program. This you are going to observe clearly. Now you check these two parts. You are going to see that they are in the correct order. 5 is smaller than 7, and in the ascending order always 5 comes before 7. So no swapping is required. No swapping is required. So don't worry about this. Then go to the next one. 3 5 7 4 2 1. You are going to check these both. You can clearly see that 7 is greater than 4, and so swapping is required. Go for swapping. 3 5 4 7 2 1. Right, and then again you come here, you see there is a increment in j. Initially j was 0, then j became 1, j became 2, then j became 3, and you are going to compare with the next element of j. So when you are writing the code, you will clearly know that what exactly is happening here. Now if you compare these both, you can see that they are in not correct order, so there will be a swapping. And you should know the swapping algorithm, because that is the root operation that you are going to do here. Then again you come here, again you are going to swap 3 5 4 2 1 7. Now clearly we can see j took maximum value till here only. Since n is 1, 2, 3, 4, 5, 6, there are 6 elements. J could take only values till this, means 6 minus 1, 5. If it is 1, in programming we will have 0. Okay, so 6 minus 1, 5, means j reached only till here. It need not reach till here because you will not have j plus 1th element for comparing. That's why we are going to reach till here only. Okay, now whatever is the value that is at the end, that is the highest element in the array. You can observe that clearly. 7 is the highest among this. You managed to push the largest element at the end, and this was the first iteration. This was the first iteration. Now we'll go to the second iteration again. When you have reached till here, when you have pushed first element here, you will start the comparison again from here. Means there is a for loop, and again there is a for loop, because you have to run this again and again and again depending upon the number of values that you have pushed. I have pushed the first element here, then you need to run j from here to here now. Okay, now we'll check once. 3, 5, 4, 2, 1. Now my task is to compare only these things. Okay, this 7 is already sorted. Now try to compare these two. Now j is equal to 0, j is equal to 1. So these both will be compared. And after comparing, you found that 3 is smaller than 5. It is in correct order. No swapping is required. So swapping is equal to 0. Then 3, 5, 4, 2, 1, 7. You are going to compare these both. You just check they are not in correct order. So swapping is required. Swap will be equal to 1. 3, 4, 5, 2, 1, 7. Okay. Now again you check this case. 3, 4, 2, 5, 1, 7. Again you check this case. 3, 4, 2, 1, 5, 7. Right. See, this was the last point where I came. I need not go here because I know this is already sorted. Now after coming till here, I identified that this is already sorted. So in the second iteration, we are going to have two sorted elements at the end. Two sorted elements at the end. Right. Now now your j is going to come till here. You can observe that there is a decrement in j in every iteration. In the second iteration, j will be checked till here. So 3, 4, 2, 1, 5, 7. This much is sorted. You need not worry. Now you check these both. They are in the correct order. So 3, 4, 2, 1, 5, 7. Now you'll check these both. They are not in right order. So you are going to swap them. Right. Then next you compare these both. You see, you are going to come till here only for checking. Once you come here, you find that these three are already sorted now. Sorted. So in the third iteration, third value is swapped. Right. Now you are left with these three elements to be sorted. Now again you are going to compare these two. Again see, j is going to start from 0. So 2, 3, 1. You compare these both. Then 2, 1, 3. Right. So 4, 5, 7 as it is. Now you see in the fourth iteration you found 4 elements arranged. Then in the last iteration 2, 1. Since they are not in right order, I'll write 1, 2, 3, 4, 5, 7. So this is swapped. Then in the next iteration, if it goes, you will find that these all are sorted, and that's why you need not repeat it. You will just going to print this one. Okay, print the array which is sorted. You are going to follow the same thing. In the program, you can see already I have written the program. I'll explain you this once. I'll take a function. I'll explain function by function so that you will not be confused with the bigger program. Right. Now you can see clearly that we have got a function here, a function to perform bubble sort. This bubble sort function is going to return void, means this function will not return anything, and this is name of the function. These are the basics of functions. Okay, already that you have studied in functions concept. Now there are two parameters this function is going to take. This is the first parameter, this is array. Whenever you are passing array, you should make sure that you are going to receive it in a array, and array declaration in C will take place like this, AR, in this way. This is just name of the array, and this explains that this is going to have a set of elements. Okay, and then int n, it means you are going to pass number of elements also, where you have calculated in the main function. So this function will be called by the main function, remember that one. We are going to initialize two variables, I and j, and another temp variable. And you know, here we are using temp variable for swapping. The most important operation that we use in the bubble sort is swapping, and for swapping we'll require minimum 3 variables, because let's imagine that you have got 2 and 3, you want to swap both of them. If you simply copy this value here, it will be 2 and 2, and this value will be lost. That's why what we will do, we'll use a temp variable, temp will be equal to 3, and then we'll copy this one here, and then afterwards we'll copy this temp here, so it will become 3 and 2. This way we will be using temp variable for swapping, so we are using temp here. Then if you come to swapped, this is used to identify before running both of the loops, if it has swapped all the elements. In some cases that is possible. Whenever you are solving the question, you will come to know. Now we have got the first loop, you can see for loop, which is going to initialize I is equal to 0, and then I is less than or equal to n minus 1. You know that when you have swapped 3 4 5 7, when you have swapped this is the last element, you need not run loop again for this particular purpose, because if there is one element, that one element will always be swapped. Now let's imagine that there is an array which contains 7 as the element. So sorted sequence of this one is 7 only, you need not sort it once again. You understood? So we are going to run the loop from I is equal to 0 to I is equal to n minus 1, means n minus 1 times. There were 1 2 3 4 5 6 6 elements in this. We arranged only the 5 elements, and the sixth element was automatically arranged. You should know that. That's why we are going to run I is equal to 0 for I is equal to n minus 1, and then I plus plus, this is for incrementation. And as I have told you, every time we will be checking whether we have swapped or not, because in some cases if you have a array which is already swapped, and if you are trying to swap that one, then you will know that in the first iteration itself there are no swapping required, and you need to exit from the loop saying that this is already swapped. For that we are, this is already sorted. For that we are going to use this swapped is equal to 0. Now coming to the next part, we have got another loop. As I have mentioned, we will be using j is equal to 0 to j is less than n minus I minus 1, because you found that gradually value of the j went on decreasing in every iteration. Initially j value, in the first iteration j value went till here. Okay, in the second iteration j value went only till here. Okay, you can see that j is going on decreasing, so it will be n minus 1 minus I. If it is sorted, if two elements are sorted, automatically j will be ran till here. You can see these two were sorted. Okay, that's why we could run j only till here. Okay, that's why j value will depend upon number of elements also, and value of I, means means how many values in the array are already sorted. That is also very important. Okay, and that's why you can see that this is running from j is equal to 0 to j is less than n minus I minus 1, and then there is an increment in j. Now if you look at this condition, if array of j is greater than array of j plus 1, you can see that we are actually comparing the adjacent values. This and this value is checked, Here j is equal to 0 and j is equal to 1. It means if j is equal to 0 and j n plus 1 or I plus 1 will be equal to what? The next element itself. That's why these two will be swapped. This will be swapped depending upon the requirement, right? That's why you are going to check whether the adjacent values array of j is greater than array of j plus 1. If it is true, then you are going to say that you are going to swap the elements. For swapping, just now I explained, you will require a temp variable. You are going to store the first value in the temp. Like if you want to swap 2 and 3, you are going to store this in the temp. Okay, and then you are going to assign this value here. You can see array of j plus 1 means this value is put here, so it becomes 3 and 3, and temp contains 2 now, and then later temp will be equal to this one, so it becomes 3 and 2. Initially it was 2 and 3, now it became 3 and 2. So swapping has been done, and if it is swapped, then we are going to change the variable that we have declared here. I have declared here swapped is equal to 0. Here I am going to change the value because it is swapped. Then afterwards I am going to check if swap is equal to 0, means if the swap value was never changed even after running this loop again and again, then we are going to break from the main loop, that is for loop, outside loop. Because when swap is equal to 0, I can directly say that all the elements in the array are already sorted. Okay, in this way this bubble sort is going to sort the elements, and already I have explained the mechanism here using an example. Okay, now we'll come to the second function. This was the first function. Now we'll come to the second function. This function is simply for print array function. This is a print array function. This is also going to take two parameters, the array and the number of elements. Here you are going to run simple for loop. I is equal to 0 to I is less than n and I plus plus, and you are going to simply print the elements one by one. Okay, initially I is equal to 0, so array of 0 will be printed, right? In this way this function will work. Okay, and now coming to the main function. In main function you are declaring a variable, right? In main function you are declaring a variable int, and then it is going to ask me enter number of elements, because I want to know how many elements I want to take in my array, and that will be stored in n. Any element that you enter will be stored in n, and then you are going to declare a array of size n. Okay, so this is dynamically allocating. Then coming to this part, taking input for the array elements, it will ask enter percentage d number of elements. So n is equal to 5, it means enter 5 elements, it will say, and this for loop will run 5 times. Okay, this file this for loop is going to take 5 elements as input, and then it is going to call a function for bubble sort. As I have explained here, the first one will be array and the second one will be the number of elements. So number of elements you have typed, and this is taking number of elements. As soon as you call that, you can say that this is sorted array. This function is going to give you a sorted array. Okay, and then you are going to print the elements and then exit from the main function. So we'll try to execute this once. You can see I'm going to compile it and I'm going to execute it. It is asking me to enter the number of elements. I have entered 6, so enter the number, enter 6 elements. I have entered 56, 12, 22, 45, 90, 13, 25. You can see it has taken 6 inputs. As I said that this loop will run for 6 times, and then it has called this function. It has sorted the elements. You can see 13, 22, 25, 45, 56, 90. This is arranging the elements in the ascending order. You can also arrange the elements in descending order. Just the main operation that you are doing here, it swapping, that depended upon checking the first element is greater than second element or not. Now if you just change this value, we will just try to check whether the first element is smaller than second element, then we are going to swap it. You see, then what will happen? We will compile it, we'll execute. Again we'll enter 6 elements: 34, 56, 99, 35, 67, and then 87. Now you can see automatically the values are arranged in descending order. Okay, because only this symbol will be changed, the main operation symbol, that is for swapping you are going to check whether the first element is smaller than second element or not. This is the only change for arranging into ascending order or descending order, and thus is the bubble sort algorithm. Okay, thank you.